In this video, we're going to take a look at what I refer to as special equations, or special cases. Results in these problems are different than what we've done in our previous problems. So, on the surface, when you first approach them, they're not really going to look much different. So, it's as we work them out that something strange is going to happen. And there's two different special cases, and they both have the same common property, and that is the variables can disappear out of the equation completely. And then what results when that happens is going to dictate which special case we're dealing with. So as we start this problem here, on the left-hand side, I notice I have some like terms there, an 8x and a 2x. So 8 minus 2 would give me just 6x. And there's nothing for that plus 3 there to do. On the other side, we have some distributing that needs to be done. Right? That 3 is distributing. So we multiply through. 3 times 2x gives me 6x. 3 times 1 gives me 3. Now you might notice something a little strange about this equation right now. That is that both sides are the same. Both sides are the same. And if you can recognize that right there, then cool, you'll know what's going on in this problem. If not, let me go one step further, because sometimes this actually happens first. And let's say we wanted the variable on one side. So I elected to subtract off the 6x, and then did the same thing to the other side. But because they both have 6x on both sides, both are positive 6x on both sides, then they go away. They go away. And once again, we have the same thing on both sides. Well, that statement, 3 equals 3, is a true statement, is a true equation. Just like 6x plus 3 equals 6x plus 3. Those are always true. So this is true for all real numbers. For all real numbers. Okay? And so that's what we say here. Sometimes we refer to this maybe as a dependent problem, or sometimes we call it an identity. But it's true for all real numbers. I mean, it doesn't matter what x is, because x has disappeared, and it's always true. 3 is the same as 3. The second special case, consider the equation here. 4 times 2 minus 5x plus 2 times 7 plus 10x equals 12. 4 times 2 minus 5x plus 2 times 7 plus 10x equals 12. So we begin first doing our distributing. So 4 times 2 is 8. 4 times a negative 5 would be minus 20x. And then positive 2 times 7 is 14. Positive 2 times 10 is 20x. And on the other side, nothing we can do. It's just 12. Just 12. And so at this point, we look for some like terms. We recognize that we have 20x in both, a negative 20x and a positive 20x. We also have the 8 and the 14. And so we start to put our like terms together. 8 plus 14 is 22. And here the 20x's just completely go away. So they're gone from the problem. Just like the last one, the x's are completely gone. And so on the other side, we'd have just equals 12. We'd have just equals 12. So this is not true. This is not a true statement. 22 is not the same as 12. And so here we would indicate then that nothing works. Or alternatively, we'd say there is no solution. There's no solution. That's the common answer for this. Some textbooks use this little symbol, a 0 with a slash through it, to indicate no solution. Another title we can give to this is inconsistent. Nothing works. Consistent would mean there's some kind of answer. But since there's no kind of answer here, we'd say it's inconsistent. So it just depends on the setting, on the homework question, which of these two options you'll usually see. whether it's no solution or whether inconsistent is your choice. Okay, but in either case, nothing works. And the key understanding is variables are gone, it's not true. If the variables are gone and it is true, then we have an equation that's true for everything. But if the variables are gone and it's not true, then nothing works and there's no solution.